Our next question deals with quadratics. We can tell it's quadratics because our formula here has a little 2 on it. That's the squared sign. So I'm just going to write down that formula in big letters so I can see it a bit better. Kinetic energy equals 1/2 of the mass times the volume squared. Okay, the first thing it asks us to do is to work out the kinetic energy of a ball with a mass of 1.5 kilograms traveling at 3 meters per second. So 3 meters per second, that's going to be our speed. So I'm going to put the v there. V is, remember, another fancy word for speed. Velocity is speed. And the mass is going to be my m, so I'm just going to make that my m here. So take those numbers and I'm just going to put them into my formula here. So we have kinetic energy equals 1/2 times 1.5 times 3 squared. So that's the same thing as saying 1.5 over 2 times 9. 3 squared is going to give you 9. So I'm going to do that on the calculator. 1/2 times 1.5 times 9. That's going to give me 6.75 here. You do not have to write this like this if that's confusing you. You could also write it as 1/2 times 1.5 times 9. That's the exact same thing. I just like this because it's shorter. So we get our kinetic energy of 6.75, and we measure kinetic energy in joules, so I'm going to put a J next to it, 6.75 joules. That would be our answer for part A. So for the next part, we are asked to draw a graph of kinetic energy against V for the values of V between 0 and 4 meters squared. All these words basically are saying, please draw us a graph of what this curve actually looks like. So V in this case is just like our X value. And kinetic energy, KE, is just like my Y value here. Now you'll notice we don't talk about M at all. So for M, that's not going to be a variable. We're going to keep M as the M that we were given in our question here. So I'm going to rewrite this formula just so that that doesn't confuse me. I have KE equals 1/2, and then I'm going to put in the 1.5 times 1.5 times V squared. And just to help me out, I'm going to figure out what that is, 1/2 times 1.5. That's going to give me 0.75. That helps me out a lot because now I do not have to worry about this as two different things. It's just one number in front of my V squared. So if I want to draw a graph for this, I am going to make myself a chart. And this is where this sort of thing, the between sort of thing, help us out. Because we want to know what the graph looks like between 0 and 4 meters per second. So instead of just writing any old numbers here, -1 to +5, we're going to write 0 to 4. So 0, 1, 2, 3, 4. 4 different points to graph. Perfect. So when we're looking for V, we're going to get our kinetic energy. And all we're going to do to find out what this part is here is we are going to take our V and we're going to sub it into our equation here. So I have 0.75 and I'm going to times that by 0 squared. That just gives me 0. So then for the next one I'm going to do 0.75 times 1 squared. 0.75 times 1 squared. You remember 1 squared just gives us 1, so we have 0.75 times 1. That's just going to give us 0.75. Our next one, 2. We're going to sub 2 into that equation there. So we're going to do 0.75 times 2 squared. That's 0.75 times 4. That gives us 3. For the next one, we're going to do 3 squared equals 9. We're going to times that by 0.75. 6.75. And the last one, 4 squared gives us 16. 16 times 0.75, that gives us 12. So here's our points here, 0, 0, 1.75, 2, 3, 3, 6.75, and 4, 12. So if we're going to graph this then, I'm going to keep this here and I'm just going to move it up so we get a bit of space for graphing. Here we are. So in my graph, I'm going to make just a very tiny one to save some space. I'm going to go up to 4. 1, 2, 3, 4. And then for my y here, I'm just going to do a very big scale so you get a rough idea of what that looks like. So that's going to be 10. That's going to be 20. 5, 10, 15, 20 there. So the first point I have is 0, 0. Cross that off on my graph. Next point I have is 1.75. That is not very far up at all, so I'll put it there. Next I have 2, 3. So I'm going to go up to roughly 3 here. Then I have 3, 6.75. So that's just above my axis there. And then I have 4, 12. That goes up here. And what you'll notice is you're going to get a gradually increasing curve there that goes sort of up like that. If we flip this around and did the other side, you'd notice that our curve would reflect upon itself like that. This is what we call a nice parabola. We get that nice U shape, which is exactly what we're looking for.